Hello, good evening. This is Miss Xiao here. Today, I will be sharing with you a question with regards to algebra and algebraic manipulation. This question is suitable for Secondary 3 and Secondary 4 elementary maths students. And the question here is taken from Discovering Maths 3 by Chow Wai Kyo and Yong Fuk Ming under Star Publishing Private Limited. Now, get yourself ready with some paper, stationery, and a calculator, and try working out this question. And after that, we'll go through the steps together. The question reads, the diagram shows the graph of y equals to ax squared plus bx plus c. It cuts the x-axis at a and b, and it passes through the point c, 0, minus 6. The roots of the equation ax squared plus bx plus c equals 0 are minus 1 and 3. A. Find the coordinates of A and B. B. Find the values of A, B, and C. Question C. Solve the equation ax squared plus bx plus c equals to 10. You may pause the video right now while trying the question out. Now, let's take a look at how we might come across this question and how we might want to solve it. Okay, so if you were to look and analyze the question, definitely y equals to ax squared plus bx plus c signifies that this graph over here is actually quadratic. Yeah. And it cuts the x-axis at A and B. Now, when a graph cuts the x-axis at A and B, this means that the y-coordinate is 0. Okay, so I will just put a note down at the x-axis, y-coordinates are 0. Okay, now why do I say so? Now, if you were to look, this is where the x-axis is. Okay, let's say if I were to consider this point over here, okay, my coordinate will be whatever that I have, that cuts the x-axis and 0. Yeah, okay. If I would have a point over here, it will also be represented by a point x and comma 0. So if you were to compare these 2 points, you realize that the y-coordinates are indeed 0. So therefore, point A and point B have y-coordinates that are also 0. Okay, now furthermore, it's also mentioned that the roots of the equation ax squared plus bx plus c equals to 0 are minus 1 and 3. Now, what does this actually mean? Roots of the equation, meaning the values of x. Okay, so maybe I'll just put a little note here. Okay, when y is equals to 0. Now, if you were to look at this quadratic graph, yeah, the points where y is equals to 0 are indeed at point A and point B. So since it is mentioned in the question that at these 2 points, the root is minus 1 and 3, therefore, x, okay, maybe I should put down when y is equals to 0, x is equals to minus 1 and 3. So we have 2 pairs of coordinates here. Okay, the first pair of coordinate will be minus 1, comma 0, and the second pair of coordinate will be 3, comma 0. Now, which would be A and which would be B? Let's take a look and analyze and see what A is and what B would likely be. Now, if you look, A is actually to the left of the origin. origin is the point where it's 0, 0. So anything to the left of the origin would mean that the x coordinate of A has to be negative. Now, if you look at the two answers, the two coordinates presented here, which is the one that has a negative value of the x coordinate? You realize that it's actually the first pair of coordinates. So the first pair of coordinates is actually that of A. Now, how about B? B is actually represented at a point that is to the right of the origin. So that means that it has to be a positive x coordinate. Okay, so B will be 3, 0. So that's the answer for the first part of the question. Now, let's take a look at the next part of the question. Find the values of A, B, and C. Let's see. For A, B, and C, they are small a, small b, and small c. They actually form the terms of the quadratic. Okay, and on the quadratic graph, you have point A, point B, and point C. Now, we are given in the question that point C is 0, minus 6. Let's substitute 0 minus 6 into y and see if we could get anything out of it. Okay, so equals to, yeah, okay. So what we will end up with is this. Okay, and therefore we could imply that C is equals to minus 6. And if we were to simplify this quadratic, we will have y equals to ax squared plus bx minus 6. All right, story's not over. We're going to move on to find our small a and small b. So how are we going to do that? Let's see. Don't forget that points A and points B actually lie on point A and point B here, where we found it in part A, actually lie on y equals to ax squared plus bx minus 6. So what we could do is that since we know that there are two unknowns, small a and small b, and there are two equations that can be formed based on coordinates of a and coordinates of b, if we sub that into y, that means we could actually have two equations with two unknowns. And if you get, my drift from here, we could solve it by simultaneous equation, as you learned in secondary 2. So let's try this. So let's sub the coordinates of A, which is minus 1, 0, in y equals to ax squared plus bx minus 6. Okay, so we will have this. And if we were to tidy it up, we will have a minus b equals to 6. Okay. Now, first equation. Let's look at the second equation. So we will sub the coordinates of b, which is 3, 0, into y equals to ax squared plus bx minus 6. And we will have this. Okay, simplifying. 0 equals to 9a, 0 equals to 9a plus 3b minus 6. And if we were to tidy it up, rearrange the terms, you will have 9a plus 3b equals to 6, which we could simplify by dividing each term by 3. So we will end up with 3a plus b equals to 2. This is equation 2. All right, so now we have two equations. Let's see what we're going to do with them in order to find unknowns a and b. So let's see. This is equation 1. This is equation 2. You notice that the term for b is plus b and minus b. What we could do is we could add first equation to the second equation. So equation 1 plus equation 2, what happens is that we have a plus 3a, we get 4a. And then for the b term, minus b plus b, we get 0. And it's equals to 6 plus 2, which is 8. And from here, we could find that a is actually equals to 8 divided by 4, which is 2. So that's the value of a. Now, how about finding the value of b? So to find the value of b, we sub a equals to 2 in, let's choose equation 1 since it's less complicated. So it will have 2 minus b equals to 6, and b is equals to 2 minus 6 equals to minus 4. Okay, therefore, so let's consolidate the answers. We could say that a is equals to 2, b is equals to minus 4, and c is equals to minus 6. So that's the answer for part B, which is rather long, yeah? Okay, now part C. Solve the equation ax squared plus bx plus c equals to 0. This is probably the most straightforward part of the question, since you already know what a, b, and c are. So I'll just put down the equation, and I'm going to sub in the values of a, b, and c. So this implies that it is 2x squared minus 4x minus 6 equals to 0. Let me do a simplification by dividing everything by 2. X squared minus 2x minus 3 equals to 0. And if I were to solve it, say, using any of the methods, okay, in this case, maybe I would just try a cross method. So I will end up with x minus 3 multiplied by x plus 1 equals to 0. And therefore, the value of x will be 3 and minus 1. Wait, did I do something wrongly? Oh, yeah, sorry. I think I made a mistake here. A very honest mistake. I'm so sorry. Okay, let me just try this portion again. Okay, I'm so sorry. Now, it's actually not equals to 0, but if I were to refer back to the question, okay, that's right. When we read questions, right, yeah, we must be really, really careful. Yeah, it says 10. I actually wrote down 0. It's, yeah. Okay, yeah, exam is so costly, right? Okay, so if I were to sub back the answers, what I will have is actually, the values of a, b, and c, 2x squared minus 4x minus 6 equals to 10. Okay, and if I were to rearrange the terms, I bring 10 over to the left-hand side, I will have 2x squared minus 4x minus 16 equals to 0. Divide every term by 2. This implies that it is x squared minus 2x minus 8 equals to 0. And if I were to solve this using the cross method, okay, I will end up with x minus 4 multiplied by x plus 2 equals to 0. And this would mean that my answer is 4 or minus 2. So that would be how we are going to solve this question. Yeah, I hope that this gives you a good understanding about how to go about questions like these, where it involves not just algebra, not just algebraic manipulation, but that of coordinate geometry as well. So this question builds in many topics from everywhere, and it's highly applicational. Yeah, so you know, when it's exam that's around the corner, it's not too wise to spot questions based on just one topic by itself, or you know, one here and then, you know, I mean, how you say, topic by topic, but rather it's important to practice with regards to questions that cover a few topics at a go. Yeah, because you can never know how questions are blended from one topic together with another, or even having 3-4 topics together merged into one big question. So if you find that the content has been useful to you, feel free to share it with your friends. Feel free to subscribe to the channel. And you might also want to check out my blog, my Facebook page, and explore the other resources in the YouTube channel. I hope you found this time useful. Thanks for your time. Goodbye.